Greetings and welcome to another installment of Quantslob. This is 31 in our basic application series. This time around, we're going to motor on with part 3 of our summarizing data series. Very first order of business here, before we get moving here with today's topic, let's visit our previous installment's Quantslob challenge. The question here is, would we consider country phone code as categorical or numerical, the attribute, country phone code? The phone codes listed here, we notice, are all numeral symbols. They're numbers. But the very first thing is I would have us note that these values do not really possess easily ascribable units. I would think of these values as being unitless. But more to the point, the question here is, would it be natural to say, for example, Western Sahara is greater than Poland in terms of country phone code? And I would say this would be a pretty awkward statement indeed. Therefore, I would think it would be best to consider this country phone code attribute as categorical. Categorical? Okay, so for this installment, we're going to focus on common summaries for a single categorical attribute. So let's return to baseball pitch-by-pitch event data. The number of pitches recorded as sliders is a summary statistic. Specifically, it is a frequency, which is a fancy word for count. This stat can be calculated in much the way we would expect. Computer software will simply count up every occurrence where our categorical attribute pitch type equals slider. Note here that frequency or count is a measure of popularity. Okay, the percent here is a relative frequency. It is a measure of popularity relative to the total number of occurrences. In our case here, pitches. It is calculated by multiplying our proportion by 100. So let's be clear here. Okay, so our attribute pitch type is categorical, and we are creating numerical summaries, statistics. By the way, this method of calculating our proportion, that is dividing the frequency of an occurrence by the total size of our collection, or the total number of occurrences, is a method we use descriptively to compute our population parameter. Well, it turns out that this same general approach is a very common way to compute our sample statistic proportion for the purposes of statistical inference. Moving on. A distribution is a way of expressing the popularity of values. So when we show a distribution, whether by table or by graph or as a mathematical function, we are conveying the popularity of values. And this is true whether our attribute is categorical or numerical. Now, you may be thinking, well, we just sort of did this with slider pitches. And we did, sort of. But when we show a distribution, we usually want to cover the entire domain, the entire collection of possible values, or at least as close to it as reasonably possible. Importantly, additionally, when we summarize data to express a distribution, we want to do this in a way that people can make sense of it so that it is intelligible to our audience. Now, in our baseball pitch-by-pitch data, we have an attribute handedness of pitcher. The values are labels, RHP for right-handed pitcher, LHP for left-handed pitcher. So this attribute is categorical with 2 categories. The domain of this attribute is a set with 2 elements. The label here RHP and the label LHP. So this table here we're looking at shows a distribution of pitcher handedness. It conveys the popularity of values of our attribute. We're actually showing here 3 measures of popularity. Frequency, relative frequency as a proportion, relative frequency as a percent here towards the right. Now, when we sum up the frequencies of all our categories, across all our categories, in this case, all 2 of them, we get the total number of pitches. When we sum up our proportion relative frequencies, we get 1 here, and when we sum up our percent relative frequencies, we get 100. Now, I'll point out that sometimes, especially when there are many categories, the actual sum of the individual proportions and percents we may find in a table like this one here may not exactly equal 1 and 100, respectively, because of rounding, decimal rounding. Okay, to calculate a category's proportion, we divide its frequency by the total frequency. And as I mentioned a minute ago, but it definitely bears repeating, this is most always our calculation whether or not we're performing descriptive statistics, that is treating our data set as a population, or inferential statistics, that is treating our data set as a sample. Okay, now, so as far as graphical representations for categorical variable, we have 2 popular options, bar chart and pie chart. Now, a bar chart here that's shown here is probably to be preferred between the 2. Here specifically, we have a horizontal bar chart, and it's called horizontal bar chart for obvious reasons, specifically because as we can see, the bars are horizontal. The length of the bars convey popularity. And I want to point out especially that the base of the plot here on the left, at the beginning of the bars, they start at 0, 0. Just as with the table, we can convert frequency into relative frequency. Here's a percent by dividing the category frequencies by the total number of cases and multiplying by 100. We can also, if we like, we can embellish our bar chart to explicitly show the percents of each category directly in the graph. It conveys a little bit more information to the audience. Now, how about the distribution of pitch type? So here, this table is much busier than our distribution of handedness, as here we have 16 categories as opposed to just 2. Notice that we have placed our categories in descending order with respect to popularity. The most popular is at the top, least popular is at the bottom. Why do we do this? Well, it just makes comparisons easier for the viewer. Four-seam fastball at a short glance we can see is the most popular. Screwball is very rare, but not as rare as the so-called automatic ball. Okay, so now let's look at pitch type, the distribution as a horizontal bar chart, just like we did with handedness. Notice that we're presenting popularity's frequency, and the lower limit here on the left is 0, 0. Also notice, if you will, that we're borrowing the same idea of ordering our categories, most popular at the top, least popular at the bottom, just like we did with our table. Now, some people, when we order categories in our bar chart in this way, will call this a Pareto chart, named after Vilfredo Pareto, who was a very cosmopolitan mid-19th century scientist. Very interesting person, actually. Some people would not call this a Pareto chart because, as it is presented, it's missing a graphical element, a cumulative line path. Save this for a later video, perhaps. In any case, I just thought I'd mention. Okay, so moving on. How about a pie chart? Okay, so here the totality of the circle, the pie, represents 100%. All of our categories combined. The popularity of each category is conveyed as the area or size of the respective slice of the pie. For this pie chart, I simply used a default theme from Keynote, and I think this looks okay. The software plotted out the percents along with the category names directly on top of the pie, and it did a pretty good job, I think, of avoiding overplotting, and it's pretty readable. However, we're missing 6 categories here, and remember that we really should include the full domain, if it's possible, all the categories. So we can do something like this, a little trick, just move the categories off to the side and have a line or segment indicating where they are in the pie. Overplotting, by the way, refers to plotting an asset like a word or a label on top of another, making the graph hard to read. The color palette here is a little bit strange. I think it would be better if the hue of the color matched the popularity of the category, so I changed the colors to match a style guide palette. Maybe we can add a wee bit of space between the slices to make them more distinctive. So, okay, I think that this sort of works. I have to say I still much prefer the bar chart, though. Okay, another example. We also have UFO sightings data. Okay, some details you can find in the video description below. I should say, point out that many people nowadays prefer the term UAP, unidentified aerial phenomena, over UFO, but we're just going to use the traditional term UFO. Our unit of observation in this data set is a sighting. We have a total of 80,332 sightings in our data set, and we have a categorical attribute shape of UFO. Okay, now notice here specifically we have a category triangle and we have a category delta. To me, a delta is a triangle. Notice we also have a category other, and we have 7 categories that are very rare, relatively rare anyway, at the bottom here. So what I propose is we create a new categorical attribute from this attribute in the following way. We're going to call our new attribute shape underscore Q new. The 2 original categories, triangle and delta, we're going to combine into a category named triangle/delta. We're going to combine the 7 rare categories with the other category and name this new category other/misc. Everything else, all the other categories are going to be copied over as is. And voila, here you can see the arrows show our 2 new collapsed categories. And I think that this is a little bit cleaner, a little easier to look at. Light happens to be the most popular reported shape, which really isn't a shape at all, but I imagine that's the appearance of the UFO to whoever witnessed it. Here is the distribution of our new recoded UFO shape attribute as a vertical bar chart, and you can see we have the category names plotted at the bottom here along the x-axis at an angle. This is a nice trick. It allows us to make the categories readable, the labels readable, while conserving space in our plot. Okay? You know what time it is? It's time for our Quantslob challenge. Here. What is wrong with this pie chart? Let's try one more. What's wrong with this pie chart? We're going to pick this up along with lots more exciting stuff upcoming in part 4. That's it. That's going to do it this time around. Thank you very much for tuning in, and don't forget to stay tuned for more Quantslob.